Let's start plotting some points. Okay, let's do this next one. Now, I know you're like, man, why don't you just Desmos this thing? I'm trying to prove a point here. I'm trying to prove 4 points. Here's my first point I'm going to prove. Let's start with 0. Yeah, that's right. Let's start with 0, which, by the way, will be the y-intercept. Just saying. So whatever I get when I plug in a 0 is going to be my y-intercept. So it's going to be 8 times 1/2 to the 0, which is 8 times 1, which is 8. All right, yay. Already, I know the answer to the y-intercept. Let's write it like a coordinate, because it is. 0, 8. Never miss an opportunity to write a coordinate, right? Okay, I would love to answer this next one, but we don't know yet. Actually, you probably do. So let's glance at this. Let's not even finish the graph yet. Is the function increasing or decreasing? Well, this is the growth or decay factor. And as we move from one number to the next, we will be multiplying by 1/2. The numbers are going to get smaller. This one's going to be decreasing. But let's see it on the graph. If I plugged in a 1, I'd have 8 times 1/2 to the 1. 1/2 to the 1 is 1/2. 8 times 1/2 is 4. Let's plug in a 2. 8 times 1/2 squared. 1/2 squared is, well, square the 1, square the 2. You get 1/4. 1/4 of 8 is 2. I hope you see the pattern, because you actually already knew it. Here it was a half. 8, 4, 2. Well, you're taking half every time. You could plug in a 3 if you wanted to waste your time. And you'd have 8 times 1/8, which is just 1. So let's plot some points. This one starts at 0, 8, and then goes to 1, 4, and then 2, 2, and 3, 1, and 4, comma 1/2, and 5, comma 1/4, and 6, 1/8. Okay, I hope you know what's happening. We're getting super close to the x-axis. I am going to graph this one on Desmos in just a minute. But in the meantime, let's connect some dots. And obviously, you see that this graph is decreasing. Hope you see it. If you don't see the graph is decreasing, then you're tilting your head in the wrong direction. Okay. Is the function increasing or decreasing? I just said it. It's decreasing. Feel free to just circle the word instead of rewriting it. I'm okay with that. What are the domain and the range? Let's do that. The domain, the range. Let's see. The domain of this function is going to go from -infinity to +infinity. Now, I know you're like, well, doesn't it stop over here? No. It goes up forever. This thing goes up forever and also goes to the left forever. It's just really, really steep over here. Okay, so the domain is from -infinity to +infinity. The range is, well, it looks like it starts at 0 and goes up. This thing will never, ever equal 0, which actually answers this right here. Interesting, huh? Okay, so the range of this is from 0 to infinity. Those are my outputs, and that tells me my asymptote also. However, let me revisit something. Notice we're taking half every time. This 8, 4, 2, 1 is never going to be 0. It's going to get super close but never touch 0. Okay, in behavior. Two things. Let's go to the left and let's go to the right. And each of these is going to be a little sentence. So we're going to say as x approaches blah, 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 this is what happens to y. Or as x approaches blah, 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 this is what happens to y. So let's go to the left from the right. We're going to go to the left. As we go to the left, my graph keeps going. It is so high, I can't see it, but it keeps going. So x approaches -infinity, and y, this graph keeps going up. So x approaches -infinity, and as x approaches -infinity, y approaches +infinity. Okay, let's go to the right. As x approaches, well, it keeps going forever, so it's approaching infinity. And as x approaches infinity, y approaches. Okay, well, it's not going up, and it's not going down significantly. It's getting closer and closer to 0. So as x approaches infinity, y approaches 0. Okay, what is the equation of the asymptote? Well, let's draw this right here. I said I was going to graph this thing on Desmos, and I hadn't graphed it. I'm sorry. I think I might have accidentally lied to you. This line right here is y equals 0. How do you know it's not x equals 0? Because if the line said x equals, you'd cross the x-axis and it would be a vertical line. But since it's a horizontal line, you're crossing the y-axis. So this one is y equals 0. There's our horizontal asymptote. Okay, that last one did not take nearly as long as some of the other ones. And we are going to start graphing these. And if you feel the need to go back and graph this last one, you could. I'm actually looking at my Desmos right now. I'm about to pull up an iPad and you will see what we're dealing with. I think I promised I would graph this last one, so I think I will. Of course, you're going to rewind the video and be like, did he promise that? Did he really? I don't remember if I did or not. But if it helps, feel free to do it. So here we go. Let me show you. There it is. See, isn't that neat? Notice that it levels off right here, but it actually keeps on going. Slow old iPad. It keeps on going up forever and keeps on going to the left forever. So there we go. By the way, if you were to take this out here and separate those, and separate them, and separate them, and separate, okay, never mind. It's not going to work there. And I think I've shown you this before. But if I was to go close to the x-axis somewhere, like this, if you zoom in enough, you'll see that it's actually not on the x-axis, but it's really, really close. See what I mean? It's not quite there, but it's super duper close. Okay, let's flip the paper over and keep on going. And I'm going to start by graphing this one by hand. What? We're not going to do this. Okay, check this out. Check it out. I'm not Desmosing this one yet. Notice this one. 8 times 1/2 to the x. 8 times 1/2 to the x minus 3. And then the period at the end of the sentence. Well, what does that minus 3 do? Well, I am glad you asked. You know what this thing does. We already knew what the last one did, so this is going to shift down 3. That does not look like the word down. I don't have any whiteout with me. Oh no, what am I going to do? Wait, I see some whiteout. It's across the room. Oh well. So, let's keep moving. Instead of what we had here, 8, 4, 2, 1, don't put those. Put 8 minus 3, 4 minus 3, 2 minus 3, 1 minus 3. It's the same thing, minus 3. So yeah, graph it in Desmos if you want to. I'm not yet. I will to prove a point at the end. So 8 minus 3, 2, 3, 4. 4 minus 3, 2 minus 3, 1 minus 3. And if you're wondering again where I'm getting those random numbers that I'm saying, I'm taking these and subtracting 3, okay? All right, let's plot some points. Oh, you already know this one too, by the way, right? So 0, 5 is the y-intercept. I hope you're noticing something too. Every time I'm asking for an exponential function, then we are looking at a y-intercept. If I ask for logarithmic functions, I'm asking for an x-intercept. It's just a handy little thing based on the way the graph looks and the way it kind of shifts around, for lack of a better word. Reflects, maybe a better word. All right, let's plot some points. 0, 5, 1, 2, 3, 4, 5, 1, 1, 2, -1, 3, -2. Okay, but before I go any further, Desmos if you want, but I don't see the need, really. I mean, I'm trying to show you how to do this just by thinking. And, you know, I know you have that technology at your fingertips, and it's easy to use, and go for it. Go for it. But think logically, too. Really think logically. If this is shifted down 3, and it leveled off at 0, it doesn't level off at 0 anymore. It levels off at -3. I never, ever want the technology that I use as a tool to rob me of the ability to think logically. Otherwise, I'd be the tool. And I ain't no tool. Okay, you actually just figured out what the horizontal asymptote is, and we already know several of these answers, by the way. Let's just crank through these pretty quickly. Was the function increasing or decreasing? It is decreasing. Let's just abbreviate or circle the word. What are the domain and the range? The domain did not change from one side of the paper to the other. The range did, because we shifted the whole thing down 3, but the domain still goes from -infinity to infinity. The range starts at -3 and goes up. So -3 to infinity, not including -3. This will never equal -3. It will get super close for the same reason that this one will never equal 0. Okay? What is the end behavior? I'm not even going to write the words left and right this time. As x approaches, let's go to the left. Can I go to the left? Yes, I can. And as I go to the left forever, see what I did? My graph goes up. As x approaches -infinity, y goes up towards infinity. As x approaches, okay, going this way now. And I can go this way forever. If I had an infinite amount of ink and paper and time, I could do it. But why would you want to do that? As x approaches infinity, y approaches, oh, okay, well, what's happening? Well, it's leveling off at -3. So y approaches -3. So the equation of the asymptote, I'm glad you asked, is this green line right here, which is y equals -3. Okay, there are two more. One of them is logarithmic, and the other one, I believe, is exponential. So on your assignment with this, you'll have to identify as logarithmic or exponential, but I think that's the easy part. Before I go any further, though, I just want a Desmos, because, you know, Desmos is fun. There we go. That's what I have. If I edit this, watch what's about to happen. I'm going to subtract 3. That whole thing went down 3. It was up here, it went down. Just a good thing to know. You already knew it, but now you're seeing it based on the graph that you see on Desmos. And you can see those points too, like there's one, oops, there it is, 0, 5, there's another one, 1.415, comma 0. Yeah, good luck with that one. Good luck trying to graph that. All right, let's go to the next page. And I think it is worth noting here that whatever the original graph looked like, it was shifted. How many and in which direction? So whatever log base 0.5 of x was, this was going to be 2 to the right. Now that is not going to be important as I graph this. That's not going to impact me much. It will a little bit, but it's not going to be a major issue because on the last problem, 2 problems actually, we had an original function and then we had a modification. This time we just have a modification without even knowing what the original looked like. And I am not going to get too crazy on this one. I'm going to just jump straight to Desmos. May I say something I know though? Sure, Mr. Reader, go ahead. In a logarithmic function, you have I'm going to the second problem. You don't have to flip, you can just look. On a logarithmic function, I have a vertical asymptote at 0. Now my vertical asymptote is going to be 2 to the right, so it's going to be at x equals 2. I'm just saying. Ways to think through this logically without relying on the technology to tell you everything you ever needed to know. Yes, I love technology, but not at the expense of my understanding. All right, let's get a log up in here. log subscript 0.5. Actually, you can't put a 1/2. You can't put the fraction. I've tried. It doesn't work. 0.5 and then parentheses and then x minus 2. X. Okay, this is just a plain thing. This is log base 0.5 of x. And if I wanted to, let's go in there for a second. If I wanted to shift it to the right 2, I'd put minus 2. Hope you just saw that line move. It's kind of cool. All right, let's get a couple points that we know. There's a point. 3, 0 is my my x-intercept. X-intercept because the y value is 0. Notice the vertical line here. Now I say vertical. Technically, it's not completely vertical, but it gets really, 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 really steep. And let's start graphing. Okay. 3, 0 is a point. I'm going to put it there. And I'm also going to put one more point that I know. I know 4, -1 is a point. How do you know? Because I'm looking at the graph. Like you can't see my screen right now, but there it is. Like there's a point at, here I'll show you, at 4, -1. That did not work like I wanted it to work. Where's my comma at? There it is. See, there's a dot there too. There's actually another one right there. It's at 6, -2. And if you're like, oh my goodness, I really don't care where all the dots are. I hear you. I hear you. I'm just showing you so we can have a few dots. And then, of course, there's 3, 0. So I'm just getting a couple more dots here. So 4, -1, 6, -2. I think that'll be sufficient, and it will guide what we're doing here. So let's put some points in. 3, 0, 4, -1, 6, -2. And this thing is going to go down forever. It is not going to have a horizontal asymptote. It's going to have a vertical one. And the vertical asymptote, which I actually already saw on my graph, was here. Now that is a very crooked vertical line, but we'll go with it. There it goes. All right, let's connect some dots. Woo, my goodness, I was supposed to get close to the line and not touch it. See how that turned out. And this one's gonna go just down, down forever. Down to a burning ring of fire. All right, x-intercept is at 3, 0. Is the function increasing or decreasing? You just say it out loud, go ahead. All right, you were correct, the function is decreasing. What are the domain and the range? The domain starts at, but not including 2, and moves forward. 2 to infinity. The range is everything down here to everything up here. -infinity to infinity. Okay, what is the end behavior? As x approaches, stop for just a second. We're going to go to the left. Can we go to the left forever? No. When we go to the left, we're stuck. We get stopped at 2. So as x approaches 2, I can't just approach 2. How do you know which side you're approaching from? I cannot approach from the left. There's no graph over here. I'm approaching 2 from the right. So as x approaches 2 from the right, y approaches, okay, well, this graph goes up, 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 up towards infinity. And then we'll deal with the end behavior the other direction. As x approaches 2, we're going to the left. Now we're going to go to the right. So as I go this way, I can go this way forever. So x is approaching infinity. Y, now, all right, let me pause here. You could say x approaches infinity from the left. Yeah, whatever. You can't go towards infinity from the right. There's nothing greater than infinity, so don't even try it. So you have no choice but to approach infinity from the left. Just saying, you know. Oh, I got to infinity and then I turned around and came back. No, don't. All right, as I'm going on the x-axis towards infinity, the y graph, the y values go down, so y approaches -infinity. What is the equation of the asymptote? Okay, you just saw it. Here it is. It's that green line. And you can see it on Desmos. And that line is the vertical line where I cross the x-axis at 2. So it's x equals 2. There we go. Let's flip this paper over. Let's do one more example, make sure we understand, and then we'll be good. Not that we were bad. Okay, check it out. This is your very first problem. Exact same problem, but it's not. It's shifted up 3. And this is like it's in parentheses. So we disobey when we're in the parentheses. And so we're going to go in the x direction, +1. So we're going to go right 1. So here's what's about to happen. Everything you had on the very first problem, 2 to the x, remember? 2 to the x. It's about to get shifted right 1 and up 3. You can graph it on Desmos, but I'm not yet. I'm going to pick a point. I'm going to pick that point right there, and I'm going to shift it right 1 and up 3. That dot is at 1, 4. 1, 4 is a thing. Okay? And then I can find out what happens at 2, something. So I could go, start with this point and go to the right 1 and up 3. And that would be at 2, 5. Okay, if you're like, I have no idea what's going on, and you're confusing me, Mr. Reader, I'm just translating the graph, but let's Desmos it. Close those out. This takes me a minute to type on the iPad, especially this older iPad. this jewel of an iPad. All right, 2 to the, okay, when you put something as an exponent and it's more than one term, you need it in parentheses. I've tried, it doesn't work if you don't. So if you put like 2 to the x minus 1 and you don't put parentheses, when you type that minus 1, the minus 1 drops down out of the exponent. X minus 1, there we go. And then plus 3. There we go, that's what the graph looks like. And let's just go ahead and say a few things. We know the y-intercept is at 0, 3.5. We could have found that by plugging in a 0 into the x value. And we also know the function is increasing, and let's just look at it here too. See where it's leveling off? See, it's leveling off right around where y equals 3, which we sort of knew, right? Okay. Let me draw it, and then I'll explain what I'm talking about. 0, 3.5, which answers this question. So 0, comma, 3.5. Function's increasing. And let's plot just a few points. 0, 3.5, 1, 4, 2, 5. And we're going to go up like this, and it's just going to go up way, way, way high forever. And it levels off at 3. And if you don't see it on Desmos when you graph it, if you don't know that that horizontal asymptote is at 3, then what you do know, if I could draw this a little bit better, that would be nice. My goodness, that is the ugliest exponential graph I ever drew in my life. I've been drawing these for over 20 years. All right. If you don't know that this is at 3, check it out. Back to the first problem. The horizontal asymptote was at y equals 0. But it got shifted up 3. So now it's at y equals 3. Cool, huh? Say yes. All right, the domain is from negative infinity to infinity. The range is not 3, but it does go up from 3. So from 3 to infinity. When I say not 3, put a parenthesis, not a bracket. What is the end behavior? Okay, I can go to the left forever. So as x approaches negative infinity, y approaches, well, we're getting close to the y value of 3. Y approaches 3. As x approaches positive infinity, we're going this direction, y is going up. Up towards infinity. So y goes towards infinity. And last question, what's the equation of the asymptote? It crosses, the green line crosses the y-axis at 3. And there we go.